Yeah, here we go. Let me just make sure that I can see you all and see the chat, because we're going to do some ad hoc polling in the chat. That will be like very low-key production, but it still will be super fun. Yeah, because I love to do polling in real life, like when people can actually raise their hands. That's not today, but we will do our best. All right, so first of all, thank you for having me. I heard a lot of great things about your meetup from Ari. And as he mentioned, he is a fan. So I got some of this love from him. And we wish all the best to Angel, obviously, and speedy recovery. And I'm glad that I was able to step in, and so you will have something today. We're going to talk about DevOps, and we're going to try and answer the question, is it a plot of ops people against the developers? So let's start. The first question is, how many of you are actually developers? So if you can just like put a plus in the group chat, so I will see. I know we're about 20 people. Let's see how many of you are developers, and then I will know if there are some DevOps people in the crowd. They will be able to call me on my bullshit. Hopefully that won't happen. It only works if I can say stuff without people calling me on. That's a generally true statement. All right, so yeah, so we have a good number of developers. Not everybody voted, but that's okay. So yeah, I will treat all of you as developers. Let me do that. So when we start talking about DevOps, the first question is, what the hell is DevOps? And you would think after 10 years of the existence of the term, and after 10 years that we speak and shout about it on every square in the city, people would know. But that's very, very far away from being the case. Even people who get job in DevOps don't know what DevOps is. So don't be embarrassed if you are not sure what DevOps is. We are going to figure it out today. So as I'm being introduced, my name is Baruch Sadogursky. I'm Chief Sticker Officer of JFrog. In better times, we would go get together. I would come to your meetup and bring a bunch of stickers with me. This is what I do, but also head of developer advocacy. I'm speaking with developers about technology, and hopefully by the end of the day, you will be able to understand better a little bit of stuff. And this is the most important part of this slide is my Twitter handle @jbaruch. By now, you probably realize that I'm super entertaining, and you definitely should follow me. In case you are still not convinced, my Twitter handle is conveniently on the bottom of each and every slide. Now, I hope this talk will be as much interactive as possible, so don't feel free to put stuff in chat, whatever thoughts, ideas, questions, comments, ridicule, whatever you want, just put it in chat and we will have some fun. This is my California disclaimer. This is an amazing chart from Irene Meyer's Culture Map book. As all of us work in multicultural environment, I highly recommend you to read this book. It's very good and helps understand tons about people from different cultures. As you can see, the most emotionally expressive and confrontational people are from Russia and Israel. I managed to be from both. So if I don't offend you throughout today's talk, I really apologize. And next time, I promise to do a better job. The most important slide of today's talk is this. You go to jeffrog.com/shownotes, and it solves you the problem of, hey, Baruch mentioned something, I don't remember, I wish I took a picture of the screen. No more. The slides are there, so everything you can find there. The video, I see both Josh and Mary Beth are recording, so we will have the recording for sure, and I will upload it there the minute it's available to me. All the links for everything, including Irene Zmeyer amazing book, and everything that will come down the road in this talk, everything is there. The place to comment, to rate, and the raffle that Ari mentioned, the amazing prices, the t-shirts, the Nintendo Switch, everything is there if you just go to jeffrey.com/shownotes. Okay, so next question is why I think I'm allowed to talk about developers and their relationship with DevOps. Now, the thing is that I am a Java developer. Did that for many years, for like a decade. Went all the way from the beginner to an architect and a consultant. And basically, if you ask me today what programming language I would be more comfortable with, that would be Groovy and Java still. So, developer working in a company that doing tooling for DevOps. So I've been on both worlds with one leg in each, and I think I understand the dynamic, and this is why I'm going to prove to you now that DevOps is an entirely made-up concept made up by the ops people. In order to prove that, let me bring you Exhibit 1. This is the Phoenix project. The Phoenix project is one of the most important, if not the most important book in the DevOps world. This is where kind of people who have no idea what DevOps is go and discover DevOps. And it is actually a very, very good book. It's a novel, so it's very easy to read. And it goes through the story of one person who worked in the very problematic company and managed to turn it around by inventing first and then implementing DevOps. So let's look at the people in this novel and see who are the driving forces behind DevOps. So obviously not all the characters are on the cover, but most important are. So just by looking at the cover, we can see who are the most important people in the DevOps universe. So we have Patty McTee, and she's a director of IT service support. She's an ops, the director of ops. Wes Davis, director of distributed technology ops. That's another kind of middle-level management in ops. Then we have retail ops. That's the other ops. That's sales. And then we have Steve, who is a CEO. And then we have Dick Laundrie, the CFO. This is fine. And now we're going to the most interesting one. Bill Palmer is the main protagonist. He is the hero in the book who invented DevOps together with his friend Eric, who is a board member, and won, and basically turned the company around, became the next CIO, and everything like was great. It's a happy end. So Bill Palmer is a VP of IT Ops. He is like a completely IT guy. Who else do we have? Very important character is Brent, who is a lead sysadmin. So Brent, he is your typical 10x developer, but he's not a developer. He's 10x sysadmin. And the last but not least, we have here John, who is a chief information security officer. Now, you might miss that someone is very significantly absent. Developers. The most important book about DevOps mentioned developers in the book, not in the best light, and none of them are important enough to make to the bunch on the cover. Exhibit 2, the DevOps Handbook. Once you realize how important DevOps is, because you read the Phoenix project, the next book you will go to is the DevOps Handbook. How to create world-class agility, reliability, security in technology organizations. You might say, well, that should be about development, but let's see who wrote it. And this is an amazing bunch of super talented, bright, and amazing people. Those are by, and I don't think I'm exaggerating, the fathers of DevOps. They deserve any respect we can give them, but let's for a second look at their background. So we spoke about Jin Kim. Jin Kim, he wrote the Phoenix project, and we already understood his view on DevOps. Let's look at the other three. Jez Humble, system architect, and system architect is a systems guy. He's an ops guy. Sorry, that was Patrick Dubois. Jez Humble, deputy director of delivery architecture. Delivery architecture is an ops constraint. He is an ops guy. And John Willis, who was back in the day VP of services of Chef, which was known as Ops Code. It's a tool for ops. And then he went to, he sold but he sold a couple of startups to bigger companies. In some point of time, he sold another. So I think he sold DTO solutions to Quest, and then he sold another startup to Docker. And yeah, Socket Plane, he sold to Docker, and then he became director of ecosystem development in Docker. It's all super ops related concepts and tools. So all four fathers of DevOps are either come from ops or don't see development as something of important for DevOps. Now let's see who is trying to sell us DevOps now. Let's Google what is DevOps and see what are the top results. So the first one right here in the bottom. Oh yeah, so the first one here is Rackspace. Rackspace selling cloud infrastructure. They are ops, cloud ops company. And then we have New Relic. And New Relic, you know who they are. They're doing application monitoring, completely ops concept. And then, well, AWS, ops infrastructure on the cloud. Collabnet are a little bit exception. They have some development tools as well. But then the Agile admin as in systems administrator. And then we have Wikipedia, which is fine. Atlassians are super ops oriented company. And then Microsoft Azure, another ops infrastructure on the cloud. And towards the bottom, you can see logs.io, and that's a logging infrastructure. Again, very, very ops-ish. So no matter how you look at it, when you try to see who is DevOps, most of them are ops. And now the next question is, after it's pretty clear that DevOps came from ops, the next question is why? Why ops had to come up with DevOps? You can look at it now, 10 years later, and try and reason about it. So here's Quora. How do I switch my job from system architect to DevOps, as DevOps was a job? And then there are a bunch of good advice, including, for example, go and learn Gits. So once you learn Gits, you are DevOps something, DevOps engineer, I guess. And one of the good things that happen when you have your system administrator background and learn Gits on top of it is that if that was your salary before you learn Gits, that will be your salary after you are a DevOps engineer. It's actually, what, 30% more, just like that. Sorry, 50% more, just like that, because why not? You know, there is a huge demand. Even now, even with COVID, more than 14,000 open jobs for DevOps engineers in the United States. And the idea that DevOps engineer, it's a thing also pondered now by the same cloud providers, infrastructure and cloud providers. So for example, AWS have now a certification, certified DevOps engineer. So you might say, what if ops people rebranded as DevOps to get more money? But that would be a mistake. That would be like in quantum entanglement, actually a reverse of cause and effect. The story, when DevOps began, no one expected that DevOps engineer will get more money. No one expected that you will have such a huge demand for DevOps engineers. No one expected that there will be certifications and institutes dedicated to DevOps engineers. This is all an effect of DevOps. But what is the cause? To understand the cause, let's look at what the DevOps. So you can see DevOps as an infinity loop of process that goes from coding to building to testing to release, deploy, operate, monitor, and then back to planning the next features. And when you look at this infinity loop, it looks familiar. And it might remind you another infinity shape, infinity circle of Agile. Look at that. It is literally the same, but for the development part. Here you have develop, test, release. Release means we're done. And then we collect feedback, we plan, we design, and we develop again. So this is the same diagram, but half of it. So what it looks like is that the ops people invented something that adds their own pains to our old world of the Agile circle to create this loop that will include developers in operations concerns. And I have another proof that this is the case. State of DevOps report. This came in 2000, they do it for like 5 years now, and this one is from 2019, that's not the last one, and it's deliberately not the last one, and we will get to the last one later, but this one is 2018, and this is the most important document in DevOps industry to gauge where our industry is standing in terms of DevOps. It's a very serious report. It queries 30,000 different organizations and measure them by those metrics of DevOps. So what are the DevOps of metrics? How often does your organization deploy code? So we start with the deployment. We start with ops concern. How long does it take to go from code commit to code successfully running in production? Again, we are starting to measure after the code is already done. Time to restore a service, stuff like outages and service impairment and this kind of stuff, ops concerns. And degraded service, the service is slow, the servers are, choked. Again, very ops related concerns. So all the metrics in DevOps report 2018 are very, very ops centered. And if we look at their definition of work, their definition of done, their types of work, then we can get a hint from that as well. Obviously, we want new work to be the majority of the time because new work is where features are. This is all true for both dev and ops. The question is, what do you define as work? So let's see what types of work there are in the Phoenix project and in the State of DevOps report. Well, planned work, business projects, and new features. This works great both for ops and dev. But how about internal projects? Internal projects are defined as server migrations and software updates. Changes driven by feedback on completed work, again, very, very broad and doesn't say as much, but unplanned work, support escalations and emergency outages. Again, this is very, very ops. It's all fascinating. It's great to read. It's very interesting, but it has very little to do with the work that we, the developers, do. So what work do we do? Well, for us, it's very simple. We either code new features, or we fix bugs, or we do refactoring. None of the work that described in the Phoenix project and in DORA report actually refers to developers. All those stories are the stories of how can we make the life of ops easier by including developers in the DevOps story. So I think by now it's very clear that DevOps is an ops invention to make us work harder. Next question would be, okay, without this DevOps thing, let's say we push back and we say, no, your ops concerns are not interest of ours. What will be our definition of done? What will be something that we, the developers, can say, we did our job well? There are a lot of sources to look for. The one that I look at, and I know it's imperfect, I know there is a lot of criticism, but I think in the essence, it captures what a good developer is, would be the manifesto for software craftsmanship. I know there are problems, but in general, it's a good declaration. Well-crafted software, yes. Quality is important. Steadily adding value, yes. We want to provide features that needs to be provided. Community of professionals, no disagreement here. Community is very important. Productive partnerships with other teams, of course. We are not the enemies of QA or the ops or the product. We are friends with everybody, but those are partnership. We won't let them dictate what our job is. So this again, we can take and break apart into more tangible definition of done. So if we take and break down those, we can come up with something like this. What is our definition of done? We understand what needs to be done. Yes. Our code is readable, simple, and understandable. Very important. Our code is easy to deploy. This is true, as we mentioned. We partner with the ops team to understand how it should be deployed. So our code is easy to deploy. Non-functional requirements are met, performance, throughput, memory footprint, whatever is needed. We didn't incur any technical depth, hopefully even reduce some. Our tests pass, and not only that, but generally we have good partnership with the QA team, so they took a look and they look happy. And obviously we did good quality code, and we got some code reviews from our peers and our team lead. Everything is fine. And also, how do we know that we add value? Well, we have product team that defines what the value is. So product owner took a look and they are happy, which is for us a proxy to customer took a look and they're happy, right? So product represents the customer to us, so this is fine. And I would say that this is a pretty good list of what software, a good software developer definition of done looks like. Now, there is something else that DevOps remind me, and that's the imaginary rivalry between developer and test. And again, just to make sure we're on the same page, maybe by the show of +1 in the chat, who thinks that there is no rivalry between dev and QA? We work together towards the same goal, and actually QA is helping us, the developers, write better code. If you agree with me, feel free to +1, and you know what? If you don't, feel free to -1. Josh, -1 from you. You want to unmute yourself and tell us a little bit why you think so? Josh Trump.
Yep.
Yeah.
So just in my experience working with testers, they feel like they have to prove something, almost like a hacker, to get out there and just it's their job to find a problem, so they're going to keep digging until they find that problem and put that little star on their side.
Great, legit. My question would be, but isn't it a good thing? In the end of the day, it's not a competition. If they manage to find a problem, those are good news. Once you code the fix, your code has one less problem.
That's a yes, valid point.
So basically, I don't think we have a rivalry. The fact that they're motivated finding problems is great because they actually do a good service to us. They improve our quality. As I mentioned in the definition of done, I think that we do have this professional pride in having as less bugs as possible, as less problems as possible, as less issues as possible. And if the QA helps us finding that, although, you know, it might look like a rivalry, but in the end of the day, they are doing us a service. And if we all agree, most of us, let's put it that way, that striving to equality is in our definition of done, then yes, we strive to get better quality. And sorry for the very Soviet meme, I get carried away sometimes. But the question is, what is quality, right? What can be considered like a valid concern about the quality of our product? And what I remember was 10 years ago when I actually was a software engineer and wrote code. Back then, I think we had a little bit different standards of quality. So let's go back 10 years ago and look at the website of our bank. For example, Chase. And I'm looking at Chase because they are doing a great job today. Their website, their mobile app, their digital experience is perfect. 10 years ago, that wasn't the case. 10 years ago, this is what their website was. Well, they already had login, so you could probably see your accounts, but it still wasn't this digital first experience that we have now. Back then, you expected to go to your bank for most of the things that you needed from the bank. So if they went down for 12 hours of maintenance for an update to ensure quality, to deploy better site, you go like, well, okay, that's fine. I don't need the bank to be available 24/7 because most of the things I do in my branch anyway. But today, that's not the case. Today, I frankly don't know if my branch was open during the COVID lockdown or not. I never checked because I never needed to, because I didn't go to a branch for years now. And that's because it's great, the website. So I definitely cannot afford to have 12 hours maintenance because this is unacceptable as a part of the quality. So the definition of quality changed. Another thing changed in the last 10 years is the amount of data. If you look at 2010, we had what? 20 zettabytes. 20 zettabytes of datasphere. Datasphere is every possible data. 20 zettabytes is huge. Zettabytes are generally huge. It's not just more than petabytes, it's actually more than exabytes. But since then, we already have what? 30? And by 2025, Seagate, well, they do storage solutions. They are interested party, but still 175 zettabytes. This is huge. And what it means that not only the Google's getting better, the Googles and the Twitters and the Netflix is getting more data, it means that more and more companies are graduated into the big data company. And I would call a big data company the company that cannot allow itself or just won't allow itself because it makes no sense to have a staging server in its classical term of being pair to pair. It's being exactly the copy of the production environment. This is not feasible anymore for more and more companies. So jolly were the times where we could test everything before going to prod, but this is not the case anymore. We are going to release to prod stuff that we are not 100% sure of. And we could panic about it and, just being very, very upset that we cannot change everything during the development, or we can start testing in production. This is called progressive delivery, and there are tons of different concepts that we have now to do that: controlled layout, rollover, encounter deployments, feature flags, observe it with observability tools, etc. The term that I really like is blast radius. Blast radius basically means that you deploy something to production, you expect it to explode, and then you want to minimize the casualties. You want to minimize the blast radius. You want to minimize the number of people who are suffering. And the way you minimize it is you improve the quality of your server, of your service, of the product. And if we agreed that quality is a developer concern, it's part of our definition of done, it means that production, being there when our software hits production, is part of our definition of done. This is now part of our job. And this is how we end up on being on-call meetings. It's not that the ops hate us and don't want us to sleep. It's because it's our responsibility. If we can only ensure quality in production, we need to be there when our code hits production. And that means that our definition of done have a new entry. And this new entry is SRE took a look and they are happy. Who are those mysterious SREs? It's a term invented by Google. Google made a lot of effort to make it searchable, but also to explain what it is. There is a great video by Seth Vargo and Liz Fong-Jones, and you can find the link to this YouTube video, obviously, in the show notes right here. And right here. And basically what they're explaining is that SRE implements DevOps. So those are the people who actually make the deployment automation work. What does it mean? SRE took a look and they're happy. We understand how our code is going to be deployed because we are on call, we need to deploy immediately, we need to understand how to do it. The build is reliable, repeatable, and fast. We fixed the problem. Now we need to rebuild the system. It should be repeatable, reliable, and fast. Our code is stateless because now we need to throw tons of more servers because we don't stand the load, and our code is scalable. Our code starts fast. Obviously, we have a new build. We need it to start fast, but also dies fast. We need to redeploy old services as fast as possible, so it should always go down fast. Our code supports feature flags. This goes to progressive delivery. There is a feature that doesn't work. We need to be able to turn it off programmatically through API. This is completely dev responsibility. We need to enable that in our code. Our code backwards and forwards compatible. Backwards, obviously, because there are old clients there, but also forwards. We released the new software, people updated their clients, and then we realized that it has a bug. We roll them back. Old clients, old servers need to be able to talk to new clients. This is forward compatible, and it's an important concern, which has to be implemented in code by developers. Our code emits event streams, so we can observe it and know when something goes wrong. Now, this also looks very familiar, this list. This list looks like the 12-factor app, which is a definition of a modern microservices cloud native app. And whatever we mention now is in the one of those 12 factors. And if not, there are now more factors, 16, 18, and they're all covered in this list that I mentioned. There is one more item to this list. And this one, our code is lean. And by lean, I mean saves money. And you can say, what my code has to do with saving money? And here is an example. Cloud providers will charge your company by tons of different stuff, tons of different services, and tons of different work they do for you. Some of it is directly affected by your code. Here is an example. Kafka Summit, San Francisco 2019, glory days when people actually went to conferences and heard talks by other people on stage in the same room. Amazing. Uday Sagar from Signal FX presented a talk about achieving 50% reduction in cross-availability zones network costs from deploying Kafka. Obviously, Kafka is a developer tool and it's a developer decision, and the implementation is a part of development. And here is how we save money for the entire organization by writing better code, by using better tools. So suddenly, not only the production and the deployment to production is our concern, but also the business, the money is our concern. So next time the boss mentioned that we need to have to cut costs, the solution doesn't necessarily have to be let's have layoffs or let's make our benefits worse or our condition worse. It can very well be we can switch to serverless and move to the cloud and save tons of money, and then no one will get fired and no one will have to pay for coffee. So all we need to do is be more lean and use modern solutions to saving money. It's not only the money that now the developers are responsible of, it's also happiness of the customers. We need more happy customers. What the customers want, they want new features. When do we want them? They want them yesterday. How do we able to provide more features faster? Well, we need to deploy faster. Back to the State of DevOps report, we see that elite performers who implemented DevOps successfully release code 110 times more frequently than those who are the low performance, right? So more features faster, business value, because faster deployments, and we spoke how to achieve that. Also, security. We need to improve our security. What we can do, one solution, we can hire Chief Information Security Officer. So you will have someone to blame when troubles occur. The other would be actually analyzing how we think about security and think how we can improve it. And one way to think about security is how you used to think about stopping distances when you got your driving license. So stopping distances have two very separate concerns: the thinking distance and the braking distance. Thinking distance is about how fast your brain reacts and sends signals to your foot and everything. The braking distance is the alloys of the braking pads and then the friction between the wheels and the road and this kind of stuff. Now, the concepts are different and the improvements are different. So how do we improve the braking distance? we come up with new alloys, we come up with better roads, this kind of stuff. How do we improve the thinking distance? We replace slow humans with fast machines. Emergency braking in the car that reacts automatically and brakes the car. This is how we improve the thinking distance. Those are completely different aspects with completely different solutions. Both of them are required to prevent, to be more safe. The same with security. Identification that we had been breached, fixing the bug, and then updating the production with our fix are all different aspects of improving security, and they're completely different. And with time, deploying faster becomes more and more critical, because now with Spectre and Meltdown that were discovered last year, we are in the position that we always chase after the attacker. Some threats are impossible to defeat before they attack us. The only thing that we can do is to deploy the fix as fast as possible and get back to safety. And deploying faster is about DevOps, is about the practices that DevOps preaches that allow us to be elite performance and deploy 2008 times faster our security fix to production. So what we see here is that DevOps is an evolutionary pressure. It is a way, it is a mean to an end to achieve better quality, to achieve better savings, to achieve faster features, and to achieve better security. So it doesn't matter if we like it or not. It doesn't matter who came with it first. It doesn't matter what was the original intent of it. At the moment, today, welcome to DevOps, because the business liked it, and it means that you don't have any other choice. And now it's time to understand what DevOps is. Now, we looked at this infinity loop, and we understand that it is about working together. Different silos, different groups, different departments should come together in this continuous effort. We have code, developers, we have test, QA and testers, and then we have release, deploy, and operate. This is the ops. And it means that we need people who are capable of doing all three of them on the same level, right? Well, no. The good news are that those people who can do everything, they do not exist. They are as rare as unicorns farting rainbows. And this is why DevOps engineer is a term that doesn't make any sense. If there are no people who can DevOps the entire infinity loops by themselves, DevOps is about collaboration. And if DevOps is about collaboration, DevOps engineer makes as much sense as collaboration engineer, which is obviously not a thing. You cannot have a collaboration engineer. So how do we achieve it? By becoming, investing, and finding T-shaped people. T-shaped people are people who are very good at something. They have this deep leg of a T. They are developers in the end of the day. They are ops people. They are security folks. But they also have this larger T, seeing the big picture, understanding what the others are doing in order to be able to collaborate successfully within empowered teams. When T-shaped people with different legs come together, this is where DevOps is happening. And the good news are that 10 years after Ops invented DevOps, they also understand that it's not about them. It's about everybody. And you can look at the latest DevOps report, State of DevOps report, which is available for us, 2019, and you can see how even here And remember who wrote the DevOps report? The same Jez Humble and Jin Kim. Even they now serve more developers than actually SREs or ops people. And if you look how the metrics change, look at that. They have metrics which are completely related to software development, lead time, how long it takes to develop a feature. And as kind of a fix for the problems that we saw in the Phoenix project, the disregard for developers, here as an alternative reality for the DevOps person, the Phoenix project called the Unicorn Project. And this is again, Jin Kim. In this alternative reality, the person who comes up with DevOps and then actually turns the entire company around using DevOps is Maxine, and she is a lead developer. So you can have this story from both angles, and both of them are similarly important in DevOps. And if you are scared that you are going to be dragged to the ops concepts, it is actually the other way around. Remember that SREs that suddenly are so important, they are now moving from the ops view of infrastructure to a development or a software view of infrastructure. SRE is what you get when you treat operations if it was a software problem. Software problem is us. We know how to solve software problem. So suddenly everybody are a little bit of SRE and a little bit of developers because it's all the same thing. It's all software problems. So in the end of the day, yes, DevOps is an ops idea. It's fine, but the business liked it because it provides quality, it provides savings, competitive advantage, provides security, and apparently it's not as bad as it sounds. Now everything is code, and we developers, we like code. Well, we dislike YAML, but everything else is code and it's fine. All we need to do is follow the principles and practices of software development. We know how to do it, and we're good in that. So in the end of the day, DevOps is fine because it's not a threat, it's an opportunity. It's not that we are doing more work, it's just we work differently. And that's not because it's a plot from ops people, but because this is an evolutionary pressure on our business. And with that, Twitter ads, this is why I'm here, gain more followers. Don't forget to follow me at jbaruch. When you praise this talk, IndiePie is the hashtag, I assume. DevOps, another good hashtag to mention. And Jefferson from the show notes, you remember it has the slides, we'll have the video, all the links, and the amazing raffle in which you are guaranteed to win a t-shirt, but also have a chance to win a Nintendo Switch with 2 games. And now questions. And the way it works is you just unmute yourself and ask questions as if we were in a real meetup that I hope will happen soon. Thank you.
Definitely. Yeah, everyone please unmute yourself, and if you have any questions, comments, concerns, disagreements, please feel free to voice those.
Disagreements are fun. Let's do that. This is the most provocative talk I ever gave. I don't believe everybody just, well, that makes sense and ready to go home. Well, you are home, but.
I think it was a very good talk. Thank you for doing this. You explain stuff that is hard for people to understand because it is vague. And so I appreciate that because it can mean whatever you want it to mean, really, right? And so you've kind of put at least some dots to line up in between. So it's a very good talk. I appreciate it. I kind of wanted to ask a question at the beginning. I forget what your quote was, something about ops doing something against dev. And I wanted to say, well, are you sure it's not development trying to steal the role from operations and get them out of the way, right? Because there's always this conflict of can't move fast enough. So and you kind of brought it around at the end to say that it's both sides, right? So
yeah. So in the end of the day, it's for the good of both. And I heard some arguments that claim that, well, no, it's actually the developers came with it because they want to steal our job. Well, there are people who claiming that, but what I heard most of the time, and it's actually proven by historical events, is that DevOps is, in the beginning, was ops trying to solve the huge pain of developers just throwing their stuff across the wall and walk into a bar to have a beer because they're done. They really couldn't care less about what happens. And then the ops people are there in the front lines fighting with whatever crap the developers wrote, and the pressure is on them to make it work, and they don't even have anyone to work with because the developers turn off their notifications. It's past 6 p.m. They don't care. They're done. So that, I mean, now it sounds funny and absurd, but 10 years ago, that was a real concern, and DevOps came as a real effort to solve that.
It doesn't sound funny. It sounds familiar. How's
yeah. There you go.
Darren, anybody else have any questions, comments, concerns?
Yeah, I actually like the notion of this so-called collaboration engineer. When you said it wasn't a real thing, that struck a discord with me because I've seen lots of examples of collaboration engineers at work in various roles that I've played.
Yeah, so let me kind of rephrase it, okay? Collaboration, it's not an engineering discipline. Obviously, people who promote collaboration exist, and they are critical, their existence is critical for a successful DevOps adoption because DevOps is about collaboration. It's not what people usually call DevOps engineer. If you want to talk about those people in a context of DevOps, they will be your DevOps enablers, your DevOps evangelists, your DevOps consultants if you want, but your DevOps coaches, it's not an engineering thing. There are a lot of engineers that implement DevOps on the daily basis in some parts of your organization. In the end of the day, we want every developer to implement DevOps a little bit. We definitely want the site reliability or service engineers to implement DevOps. And this is what Google was talking about. We want call them production engineers. You want to call them infrastructure engineers. And obviously the QA, all of them in the end of the day are implementing DevOps. None of them is DevOps engineer that should be in DevOps department and engineer DevOps in there.
Yeah, I can buy that if it's a question of semantics too.
Those semantics sound stupid, and my crusade on the term DevOps engineer sound absurd and just childish because I really lose my shit every time I meet DevOps engineer. But it is critically important because organization strives to fit engineers of the same specialization within departments and teams. Once you have DevOps engineer, the next thing you are almost guaranteed to have is DevOps department. And DevOps department is a silo that you discover that it's actually a rebranded ops department, and then you are back to square one. You need now to foster collaboration between dev and DevOps. And then you come with a new term. How about DevDevOps? DevDevOps is when you want dev to collaborate with DevOps, right?
Yeah, this sounds like Inception all over again.
Exactly. So this is why I passionately hate the term DevOps engineer, because it promotes DevOps silo all over again.
So I thought I'd ask this question because from what I'm hearing is basically a lot of things are based on semantics or the reality of how a group of, let's say, DevOps or devs or ops, they're structured. So my question is, what is the reality of that today as we speak here in this Zoom room and, of course, in the industry?
That's a great question, and fortunately, we can answer this question with numbers. And this is why I mentioned the importance of the State of DevOps report, because it's a scientific research into the state of DevOps. And if you look at that, you see that, let me just find the 2019 one, and I will share some insights with you, because it's really, really, really good. Let me find it, state. Here we go. Yeah. All right. So I'm going to share my screen one more time. Where it was here. Here we go. So this is the latest, and I don't know if we will see a new one, because Dr. Nicole Forrest-Green, the chief scientist of the project, they had this company that is called DevOps Research and Assessment. I think it was group or institute. It was acquired by Google Cloud a year ago, and then they released the 2019 report, and then she actually left to GitHub like half a year ago. So I'm not sure if we will see more of State of DevOps report. I hope we will, but that's the last one we have. And if we look here, where are the numbers? This. No, not this. This. So look at this. 2019. So before 2019, they had three cohorts: the high performance, the medium performance, and the low performance. In 2019, they had to introduce a subsection in the high performance called the elite, because some companies actually opened such a big gap, even from the high performance, that grouping them together didn't make sense. And in 2019, this group actually grew 3 times so much that now, apologize, that now they are an entire cohort by themselves. 20%, every 5th organization in the world do this. On demand, multiple deploys per day. Remember, this is what provides faster features and better security. Once we have a feature, our customers can enjoy it the same day. Once we have a security fix, we can patch the security hole immediately. And then they have less than 1 day lead time for changes. From the minute the code is done, how fast it will be, it is ready to deploy. Time to restore service. The service is done. Less than an hour and it's back up. And change failure rate between 0 and 15% of their releases have bugs or something to fix, which is extremely low numbers. Compare that to the low performance. So back to the numbers. Where are they? Here? And you can see that even together, elite and high performance, they are suddenly less than high performance. So last year, 48% included the high performance. So almost half of the industry actually performed better. This year, it's only 43%, but the high performers getting better. Some of them also fall back to this medium performance, and we see the number of low performance actually reduce when people getting better. So what we are seeing here is a typical distribution of this Darwinistic evolutionary pressure. The good are getting better, and we have the peloton, we have the medium performers are getting faster, are getting better, because some fallback couldn't stay the pressure, and then the low performers are going to disappear very soon. So this graph is, you look at that and you understand that the industry is changing. Does it make sense?
It's starting to make sense, yes.
Yeah.
I guess more along the lines of, there's always room for improvement, and companies who are basically in DevOps or in whatever structure that they are in, by the numbers, it's looking like they are looking to basically, mentor people into better performance.
Absolutely. Absolutely. Yes. It's both happening inside companies. The good are getting better because they have the culture, right? And this is where the change is. And well, you mentioned in the beginning something that kind of struck a chord, that you said, well, it's all small things and definitions and nuances. Well, this is a very good definition of culture. Any culture is about definitions, small changes in how you behave, and it's not about code. It's not about engineering practices. It's not about all the things that we developers feel so comfortable is. DevOps cannot be solved with technical solutions. There is no tool that you can buy that will create DevOps in your organization. It is about behavior. It is about stuff, ridiculous stuff like organizational structure and titles, if you wish. And it is about the ridiculous stuff of how often people meet and where they sit and how they eat. And this is where the culture changes, not in your data centers.
All right. Well, thank you so much for answering that question. It definitely gives me a little bit of an understanding.
Yeah, and I understand your frustration, because it's hard to acknowledge that you can't solve the hardest problems with technology, because as engineers, as developers, this is what we do. We solve problems with technology, and admitting that we cannot do that is extremely painful, extremely hard, and this is why those ridiculous DevOps as a service and DevOps in the box exist.